Number 1, it looks kind of like a square. So we studied squares and cubes, and you're testing on squares and cubes, and you should recognize these numbers as perfect squares. So this one's a little bit different than number 2 because number 2 has a middle term, and number 1 just has a first and a last, but they're both perfect squares. If you ever come across your first and your last that are both perfect squares, like all 3 of these, then it's a special case, and it's pretty easy. So square root, we need to multiply. If you're going to factor it, you need to change it to a times problem. So it's going to look something like this. And how they got 25n squared is they multiplied 5n by 5n. So when you distribute, you times it, and that 5n times 5n is going to give you 25n squared. And then the last, how they get a 16 is they times a 4 and a 4. But they need to multiply and get a negative 16. So one of them's got to be positive and one of them's got to be negative. That's the only way you can times and get a negative, if you have one of each. So now here's why they don't have a middle. If you times the 5n to a negative 4, that's a negative 20n. And if you times the 4 to the 5n, that's a plus 20n. And a negative 20n and a plus 20n, that's 0. But a 4 times a negative 4 is going to be negative 16. So that's how they end up with 25n squared minus 16. Number 2 has a middle term, but we're not even really going to worry about it. You're just going to look at your first and your last, and if they both start with squares, then you're going to follow this model. They multiply to get a 25m squared, they multiply a 5m and a 5m. They multiply to get a 4 by a 2 and a 2. And since the middle now is positive, I know that it's got to be a plus and a plus. So you can check it real quick. 5m times 5m, that's 25m squared. 5m times 2, that's 10m. And 2 times 5m, that's another 10m. So that's how they're getting the 20m, is they add 10m and 10m. And the last one is 4. So you can write it just like this. 5m plus 2, that whole quantity squared. Number 3, same thing. We're going to ignore the middle. We're just going to look at the first and the last. And when you recognize they're squares, then it's going to be easy. 5r times 5r. 3 times 3 will give you 9. But the middle has to be a negative 30, so it's got to be minus minus. Okay, number 4. 5 is not a perfect square, and neither is 125. So it's not going to follow that model, but we can divide both of these by 5. And if you do that for your first move, then you get this, 5 times x squared minus 25. And now they're both perfect squares, and now it looks kind of just like number 1. So it's going to be 5. How they got an x squared was x times x, and how they got 25 was 5 times 5, but it's a negative 25, so one's got to be plus, one's got to be minus. There is the answer. The next 2 are cubes, and you got to recognize 216 as a cube, and you need to write it as a cube. 6 cubed, a cubed, and 125, you need to know that's a cube, that's 5 cubed. Okay, when you're looking at cubes, all you really are looking at is the base of the first, we'll call that base of 1, and the base of the second. So the base of the first is 6a, it's without the exponents, and the base of the second is 5. So now if you know the base of your first and the base of your second, and you're adding them, then you just follow this model. It's going to be the base of the first plus base of the second. So base of my first is going to be 6a, base of the second is a 5, and then you do the base of the first squared. So 6a times 6a is going to be 36a squared minus times your two bases together, a times b. So 6a times 5, that's 30a, plus the last base squared. And 5 squared is going to be 25. So that is your answer. Number 6, you need to see the cube. And you need to recognize 64 is a cube and 27 is a cube. So you need to write it as cubes. 4 cubed x cubed minus 3 cubed. Okay, the first base is 4x and the second base is 3. So subtract is pretty similar. It's going to be 4x subtract 3. That's in the first group. The second group is the first base times itself. So that's 16x squared. And now it's going to be plus and plus. The middle is the same, times them together. This base times this base, that's going to give you 12x. The last is going to be this base times itself, so it's 9. There you go, that's it. Number 7. Okay, volume. Volume is length times width times height. But it's abstract because they're not giving you numbers, they're going to give you algebra. So it really does not matter which one is the length, which one is the width, which one is the height. I guess they're using depth instead of height, which is the same thing. They're giving you the depth. The depth is x plus 2. So if I take this times this times this, so if I say the length is 2, the width is 3, and the height is 4, you times them all, and that's 6 times 4. The volume would be 24 something cubed, because volume is cubed, that's third dimension. So you got a cube right here. This is third dimension. You times 3 things, and it gives you x cubed minus x squared minus 10x minus 8. But they're only giving you one of them. So can I find the other two? And I know that if I go forwards, I times them all, and that will give me the volume. But now I got to go backwards, and backwards of multiplication is division. So, and because this is a 1, I can use synthetic division. So if I divide my volume by the depth, it will give me what I times by to go forward. So I'm going to use synthetic division. That's going to be a negative 2 in that box. 1, 10, 8. Okay, so I'm going to put a 1. I'm going to put a negative 1. I'm going to put a negative 10. And a negative 8. And this is going to be my remainder column. So I bring the first one down, that's 1. I times them. Negative 2 times 1 is negative 2. Negative 2, add them up. That's negative 3. Times them, that's a positive. Is that a positive 6? Add them up, that's a negative 4. Times them, that's a positive 8. So that's 0. Okay, so what that means is when I go forward, if I take my depth, which is x plus 2, and I times it by what I just found, 1x squared minus 3x minus 4, that gives me x cubed minus x squared minus 10x minus 8. And this can be broken down into two factors. I can factor this down to something even smaller. So what's going to times give me x squared? X and x. What's going to times and give me a negative 4? But add and give me a negative 3. A negative 4 and a plus 1. So these are the other two factors. It does not matter which one's which. X minus 4 could be the length. X plus 1 could be the width. So it's just a division problem. And then you got to factor down, always factor as far as you can go. Okay, 8, same thing. It's the answer. So if I give you 12, and one of the factors, I'm asking you this, 4 times what is 12? X minus 3 times what is x cubed minus x squared minus 5x minus 3. So to undo multiplication, you need to do division. 12 divided by 4, the answer you're after is 3. So you need to do division, and because this is a 1, I can use synthetic division. So I'm going to put a 3 there, a 1, a negative 1, a negative 5, a negative 3. That's going to be my remainder. Bring that down, times it, add it, times it, add it, times it, add it, and we got 1, 2, 1. So what that means is 1x squared, because you always do 1 less. This guy was a cube, this was a squared. You always do 1 less than what you start with. So if I start with a cube, my answer is going to be a quadratic. X squared plus 2x plus 1 is my answer. But the question is, can you break that down? Does that factor down into something even smaller? And yes, it does. What's going to times and give you x squared, x and x? What times is this? Gives you 1, adds and gives you 2, plus 1, plus 1. Okay, number 9. Same thing, and we again can use synthetic division because it starts with a 1. So if it was like 2x plus 4, you cannot use synthetic division. You got to divide that out the long way. So if we can use synthetic, let's put a negative 2 in there, a 1 cubed, a 2x squared, a negative 1x, and a negative 2. So bring it down, that's 1 times it, that's negative 2, that's 0, times it, that's 0, add it up, negative 1, times it, 2, add it, that's 0. So I'm going to use these numbers to give me an answer. It's going to be 1x squared plus 0x minus 1. Can you break it down further? Yes, you can. What's going to times give you an x squared, an x, and an x? What times this gives you a minus 1, but adds and gives you nothing? Minus 1 plus 1. So that is what we're after. What polynomial function will give you a double root? So that's 2 roots at 2 and 2 roots at a negative 3. So if my root is at 2, then my polynomial is going to look like this. But if I have a double root, I've got 2 of them. So my roots are the zeros. If I plug this into the polynomial, it will give me a 0. 2 minus 2 is 0. 0 times anything is 0. So these are my double roots. There's going to be 2 of them. Now, I'm going to distribute this and figure out what that polynomial really is. X times x is x squared. X times a minus 2 is a minus 2x. A minus 2 times x is a minus 2x. Minus 2 times a minus 2 is a plus 4. So the polynomial really is x squared minus 4x plus 4. That is the polynomial that gives me a double root at 2. The polynomial that gives me a double root at a negative 3 is x plus 3 times x plus 3. And if I distribute that forward, it will give me the polynomial x squared plus 3x plus 3x plus 9. So it's going to be x squared plus 6x plus 9. Now if I take this polynomial and multiply it by this polynomial, that will give me the grand polynomial that gives me 2 double roots, one at 2 and one at negative 3. So let's see if I can move it up here. Whoa. Okay, because there's going to be a lot of distributive. So I'm going to times this to this. X squared times x squared, that's going to give me x to the 4th. X squared times 6x, that's going to give me 6x cubed. X squared times 9, that's going to give me 9x squared. Okay, that's done. Now I'm going to times this through. Negative 4 times x squared is a negative 4x cubed. Negative 4x times 6x is a plus 24x squared. Negative 4x times 9 is a negative 36x. And then, blue. Let's do 4. 4 times x squared is going to be 4x squared. 4 times 6x is 24x, and 4 times 9 is 36. Okay, now add up your like terms. so I only have one of the x to the fourth. I got a couple cubes. If you add your cubes, they should give you 2x cubes, and if you add your quadratics, 24 plus 9 plus 4 is that 37 squares. Then add up your linear pieces, negative 36 and 24, negative 8x's. It's more than 8. How much is it? Is it 12? 12x's. Okay, and then 36. So this is it. This is the polynomial. So write a polynomial function, so just that equals y. So if you graph that on your calculator, it will have two double roots at 2 and a negative 3. 11. Okay, what could be the number of real roots or zeros? A quadratic. A quadratic is degree 2, so it's a polynomial. So all you gotta remember is this. The imaginary roots come in pairs. They come in conjugate pairs. So there's no way, there's going to be two roots. If it's a quadratic, that means there's going to be two roots. There's no way to have one real and one imaginary, because you can never have loner imaginaries. They always got to be in pairs. So you've either got to have a real and a real, or you've got to have an imaginary and imaginary. So you can have two real, or you can have 0 real, because they both could be imaginary. Okay, if it's degree 4, that means there's going to be 4 roots. So you could have real, 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 real. You could have real, real, imaginary, imaginary. Or you could have imaginary, 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 imaginary. So let's go with this one. You could have 0 real, you could have 2 real, or you could have 4 real. Any of those will work. 13, they want you to do a composition. They want you to take 2 and first plug it into G. So you need to take this 2 and replace it with the x. So it's going to be a negative 2 minus 5. Just swap the x out, nothing else. So that's going to be negative 7. Now take that negative 7 and take it next into f. So negative 7 is now going to go into f. So f says negative 3 times a negative 7 plus 4. So negative times negative, that's positive 21 plus 4. You should end up at 25. 14. 14, I want you to kind of do the same thing, it's just written different. This little circle means composition. So take negative 1, plug it into h first. Whatever one is closest to, that's where it goes first. So replace the first n for negative 1, and then replace the second one with the negative 1. So negative 1 squared, negative 1 times negative 1, that's positive 1. Negative 5 times negative 1 is positive 5. If you do the math, that should give you 6. Now take that answer and plug it into G. Take 6 and plug it into G. So now it's going to be 2 times 6 minus 1. 2 times 6 is 12. 12 minus 1 is 11, is where you should end up. 15. Okay, 15, they just want you to subtract them. So they want you to do f, negative 4x plus 3, and then subtract g. But g, you have to subtract whatever g. G has two terms. You need to subtract the 2x, and you need to subtract the negative 1. You have to subtract both of them. So negative 4x and a negative 2x, that's a negative 6x. But 3 subtract a negative 1 is really a 4. So your final answer should be negative 6x plus 4. 16. They want you to times them. So they want you to do g times h. So g is x minus 3. H is x cubed minus x squared. times them. X times x cubed, you have to distribute, that's x to the fourth. X times a negative x squared, that's a negative x cubed. Negative 3 times x cubed is a negative 3x cubed, and a negative 3 times a negative x squared is a positive 3x squared. So if you add your like terms, you just have x to the fourth minus 4 cubes plus 3 squares. That's it. 17. Okay, now you're looking at a picture. It's the exact same though. And a picture actually might be easier. You have two functions. This one's f, this one's g. So negative 1 is like a table. You're going to plug a negative 1 in, and the question is, what does it spit out? So if you plug a negative 1 into f, so this is my x-axis right here. I got to find the dot that matches up with negative 1. So this is my f line. This is where I'm looking. So I start at 0, 0. If I go negative 1, that's left 1. I'm going to have to go right there to touch the graph. I had to go up 2. So 2 is the answer of negative 1. Now, take that answer, take 2, and now you're going to plug it into g. So start back here at 0, 0, go over to 2. That's what you just plugged in. Now touch g. And to touch g, I have to go up 3. That is it. The answer is 3. That's where you end up. 3 is the answer of 2. 2 is the answer of negative 1. Okay, number 18. 18. Start with 6. Let's plug 6 in. What is the answer to 6? But you got to look at the g. So I'm going to come over to 6. And to touch g, the answer of 6 is 3. Okay, now take that answer and plug it in, and you got to go to g. So plug in 3, come over 3, touch g. You're touching at 0. So 0 is now the new answer. Take that new answer, take 0 and plug it into f. So 0 plugged into f gives you a 0. Okay. 19. Okay, 19, there's multiple answers. You gotta make up your own, as long as the answer's 6. So let's take negative 2 and plug it into g. So if I say g of x could be this. G of x could be 2 times whatever you want to plug in. Now, if I plug in a negative 2, 2 times a negative 2 equals a negative 4. Now, I got to take that negative 4, and I got to plug it into f. But remember, I got to end up at 6. So I'm gonna do this. The rule for f says 10 plus whatever you plug in. Because if I have to plug in a negative 4, 10 plus a negative 4 will give you 6. So that will work. G of x is 2 times x, and f of x equals 10 plus x. That's one of many that'll work. You just kind of got to be creative. Okay, number 20. Let's go backwards. I give you the roots. The roots are 0, 2, and negative 3. So x minus 0, that's the same thing as x, so I'm not even going to write anything. If your root is 2, then the polynomial needs to be x minus 2, because that's what you plug in to get 0. And if your root's a minus 3, it's going to be x plus 3. Okay, now distribute through. X times x is x squared. X times negative 2 is a negative 2x. So I'm going to take that answer, x squared minus 2x, and I'm going to times it to the x plus 3. So times this to this, that's x cubed, times this to this, plus 3x squared. Negative 2x times x is a negative 2x squared. Negative 2x times 3 is negative 6x. So x cubed plus x squared minus 6x. That's the polynomial that gives you those three roots, and those three roots are all real. Okay, well, polynomial will give you 2 and 3i, but if it gives you 3i, it's also giving you a negative 3i, because your imaginary's got to come in pairs. So this is 1, 2, 3 roots. If it's 3 roots, it has to be some type of a cubic, something cubed. So I'm going to do the imaginary roots first. X minus 3i, that's one of the polynomials, because 3i minus 3i, there's a 0. My other polynomial is going to be x plus 3i, and if I do x times x, that's x squared. X times a plus 3i, that's plus 3ix, and a minus 3i times x is a minus 3ix, and those are just 0. And a negative 3i times 3i is a negative 9i squared, but an I squared is a negative 1, so negative 9 times negative 1 is positive 9, so you got x squared plus 9. That's for the two imaginary roots. Now your other root was the 2, so it's going to be x minus 2. You got to times that by x squared plus 9. So x times x squared, that's x cubed. X times 9 is plus 9x. A negative 2 times x squared is a negative 2x squared. A negative 2 times 9 is negative 18. And there's nothing that are like terms, so that's it. That's your answer. So you could write equals y, and then now it's a function. Y equals x cubed plus 9x minus 2x squared minus 18. Okay, 22 and 23 are just like it, except for there's millions of right answers. There's not one right answer. Write a quadratic equation that'll give you 2 real roots, so make up your own roots. Maybe your roots are 4 and 3. So then your polynomial would be x minus 4 times x minus 3. And go one step further, distribute x squared minus 3x minus 4x plus 12. So x squared minus 7x plus 12. There's your polynomial that will give you 2 real roots. So you just make up any 2 real numbers that you want. If you need to create something that will have 2 imaginary roots, remember, if you choose an imaginary, if I choose 5i, then the other one has to be a minus 5i. So those are the 2 imaginary. You can choose any 2 you want, but they got to be pairs, they got to be conjugates. So now it's going to be x minus 5i times x plus 5i. So distribute x squared, but this is going to cancel with this, so I'm going to skip it and just do a minus 25i squared, and I squared is a negative 1, and then negative 1 times a negative 25 is a positive 25, so x squared plus 25, there's my function. Okay, the bonus is a composition, but they don't want you to plug in a number, they want you to plug in an expression. So plug this into f first. Okay, f says whatever you plug in times it by 2, then plus 1. So if I plug in a negative 3t, I'm going to times it by 2, which is going to give me a negative 6t plus 1. Okay, now I have to plug that into g, and g says whatever you plug in, you got to square it and then subtract it. So I'm going to plug in place of those t's, I'm going to put a negative 6t plus 1, negative 6t plus 1. Okay, now I got to do a negative 6t plus 1 squared, which is a negative 6t plus 1 times itself, a negative 6t plus 1. So if I times my negative 6t, that's positive 36t squared. Negative 6t times 1 is negative 6t. 1 minus 6t is negative 6t. 1 times 1 is 1. So 36t squared minus 12t plus 1. Now I got to minus the 6t, and I got to minus the 1. So 1 and a minus 1, those are going to zero out. So those are gone. A negative 12t minus 6t is a negative 18t, and then 36t squared. So it should clean up to that.